Today we're going to look at solving two-step proportions. And if you look at example number 1, it looks like an equation that you've already solved in the past. And it is. This is actually a one-step equation. And so if we want to figure out what number makes this equation true, all we have to do is isolate the variable using inverse operations. Since this 5 is connected through division, I know that if I multiply 5 to both sides of the equation, I'll be left with n equals, and 5 times negative 4, if I made 5 a fraction, 5 times negative 4 is negative 20, and 2 times 1 is just 2. And I can further simplify negative 20 divided by 2 to negative 10 equals n. And so we just solved this equation using inverse operations like we've done in the past. However, I want to show you a special type of way to solve an equation that looks like this. Because negative 4 over 2 and n over 5 are both fractions, we're trying to figure out what number for the variable makes these equivalent fractions, or equivalent ratios. And there's actually a shortcut, and it's more mechanical than solving equations like this. So we want to make sure that you understand when you use this shortcut, what you are doing is in fact exactly what you did over here, which is using order of operations. So the shortcut is, I can cross multiply my ratios by multiplying the numerator of one of the ratios by the denominator of the other ratio, and the denominator of one of the ratios by the numerator of the other ratio. So I'm going to multiply these together, and then I'm going to set them equal to each other. So negative 4 times 5 equals 2 times n. And I can simplify this to negative 4 times 5 is negative 20. 2 times n is just 2n. And now I'm just going to solve for n by eliminating this 2. Since it's connected through multiplication, I know that if I divide both sides by 2, I'll be left with n equals negative 10. And you'll see that the same exact answer we got in the first way we solved it is the same exact answer we got the second way. And when I type this into the answer blank, I don't need to type n equals because it's already given to me. Example number 2. 4 over 3 equals 3 over x. Again here, if I was to use inverse operations, what I would do is, first I'd have to get my variable that I'm solving for out of the denominator by multiplying it to both sides. Here I have just 3. If I made this a fraction, x times 4 is the same thing as 4x equals 3. Now I have it into the numerator, so all I have to do now is use inverse operations to isolate it. So I've got to get rid of the 4 that's being multiplied and the 3 that's being divided. Well, the inverse of division is multiplication, and the inverse of multiplication is division. So I'm going to go ahead and multiply that same exact thing to the other side. And what I get, I'm going to turn this 3 into a fraction, what I get is x equals 3 times 3 is 9 over 4. And again, I'm going to show you the shortcut because we have two fractions and we're trying to figure out what value for the variable makes these equivalent fractions. We can use our cross multiplication shortcut by multiplying the denominator and the numerator and the denominator and the numerator together and then setting them equal to each other. So 4 times x equals 3 times 3, and I can simplify that to 4x equals 9, and then I just use inverse operations here to eliminate the 4, and I'm getting the same exact answer that I did when I solved it using inverse operations. And you're going to get a lot of fractions on these problems, so don't be alarmed. And I just type it in like this. Example number 3. So now that you know that when you're cross multiplying and solving for the variable, it's the same exact thing as solving for inverse operations. We're just going to go ahead and do the rest of these examples using cross multiplication. So here I have v times -5, and we're going to always take the negative. If there's one negative in front of the fraction, let's just always put that in the numerator. So we're going to say v times -5 equals -6 times 4. And here I have -5v equals a -24. Now if I want to eliminate the -5, I know that I need to divide since it's being multiplied, both sides, and I am left with v equals, I know that a negative divided by a negative is a positive, 24/5. Now can I simplify these? Is there a number that I can divide both the numerator by and the denominator by? Well, 5's prime, the only numbers you can multiply to get 5 is 5 and 1, and 5 doesn't go into 24. So that's as simple as it can get. So I'm going to come up here to my blank and type in 24/5. Example number 4. 2/5x equals 5/10. I'm going to cross multiply. So I have 2 times 10 equals 5x times 5. That's 20 equals 5 times 5 is 25 times x is 25x. Now I need to get x by itself, so I'm going to divide by 25, divide by 25, and I have x equals 20/25. Now can I simplify this fraction? Well, I know that 5 goes into 20 and it also goes into 25, so I'm just going to divide both of these by 5 to simplify my fraction, and that equals 4/5. And when I put that into my equation or my answer blank, I just type 4/5. Example number 5. 9/7 equals -7/r. We're going to go a little bit quicker now. We know that we're going to cross multiply, so 9 times r is 9r, and -7 times 7, remember we're taking this negative with the numerator, is a -49. And now I'm going to solve by dividing 9 by both sides. R equals -49/9. Can I simplify this? Is there a number that goes into 49 that also goes into 9? Well, I know that 7 times 7 gives me 49. Is there any other combination? I can't think of one, so we can't simplify this fraction. So we're just going to type in -49 divided by 9. Example number 6. Again, we're going to cross multiply, so here I have 3/9 equals v/5. We're trying to find the value that gives us equivalent ratios. So I have 3 times 5 equals 9 times v, which is 15 equals 9v. Going to isolate v by dividing both sides by 9. And I have v equals, I can actually simplify 15/9 because I can think of a number I can divide both of them by, which is 3. And I get 5/3. And you're going to want to type in the fraction in its simplest form because that's the way the computer is going to read. Okay, so we had some technical difficulties, so I'm going to skip over 4/5. Good. And we just finished 7. Okay, example number 7. I know that I'm cross multiplying, so I know that 5 times 7 equals 2 times a. 35 equals 2a. Now I'm going to eliminate 2 by dividing both sides by 2. So I have 35/2 equals a. And there's not a number that I can divide in evenly to both of these because this is an even number and this is an odd. That's not necessarily why, but I know that 2 doesn't go into 35. So I'm going to come up here and type in 35 divided by 2. Example number 8. 6/8 equals k/2. I'm going to cross multiply 6 times 2 equals 8 times k, which is just 8k. And now I'm going to simplify this real quick. 12 equals 8k. Divide by 8 using inverse operations, and I have 12 over 8 equals k. Because I can already identify a number that both of them can be divided by, I'm going to go ahead and simplify this fraction to 4 goes into 12 3 times, and 4 goes into 8 2 times. Come over here, 3 over 2. Five over 2 equals 3 over b. What number is going to make these equivalent ratios? Let's find out. 5 times b equals 3 times 2 is 6. Again, I just cross multiplied my denominator with the numerator of the other fraction and the numerator with the denominator of the other fraction. Now I'm going to isolate b. I'm going to divide by 5, divide by 5. b equals 6 divided by 5. And there's not an answer. I can't type this one in for you, but you would type it in as 6 divided by 5. Example number 10. Again, I'm just going to cross multiply, and I'm going to make sure that that negative goes with k when I multiply. So I have 4 times 8 is 32 equals 2 times a negative k is just a negative 2k. Now I'm going to divide both sides by negative 2 to get k by itself, and I'm left with negative 2 goes into 32. Well, 2 goes into 32 16 times, and a positive divided by a negative is a negative equals k. And I can't simplify that further, so I'm going to go ahead and type in negative 16. Example number 11. I have negative a over a equals 2 over 9. We're finding what number for the variable makes these equivalent ratios. So I'm going to cross multiply, and remember that that negative is going to go with the a. So I have negative a times 9 is negative 9a equals 8 times 2 is 16. And I'm going to divide both sides by negative 9. Here I'm left with a equals a positive divided by a negative is a negative, and 16 divided by 9 cannot be simplified because I can't think of a number that goes into both the numerator and denominator evenly. Example number 12, our last example. 10 over 5 equals n over 10. What number makes these equivalent ratios? I'm going to cross multiply. 10 times 10 is 100, and 5 times n is 5n. I'm going to divide both sides by 5, and I'm left with, if I don't know how many times 5 goes into 100, I'm going to create my division box. 5 goes into 1, 0. 5 goes into 10 twice. 2 times 5 is 10. I'm left with 0. 5 goes into 0 0 times with no remainder. So I know that 20 equals n. Again, we're using cross multiplication because we know that solving proportions by cross multiplying is the same thing as solving equations using inverse operations.